Yeah, thanks again for coming back from the break. I hope you had a good time. So yeah, I'm going to be presenting on an automated flagging system for Excalibur. So this is what I've been working on this whole summer, and it's still in its baby phase and it hasn't been put in the public portal, but it's going to in future releases. So with that, I wanted to talk about the traditional way of validating transit spectra. So usually we just look at the spectrum and think, is it good or bad quality? And everyone has a different way of doing this, and it's not a uniform way across different people. So it's hard to reproduce it across different planets. And the whole point of Excalibur is to do uniform processing for comparative planetology. So it makes sense that a system with uniform processing should have uniform validation. So that's what I've been working on. And as Excalibur is expanding with more targets and instruments and missions in the future, it's not feasible for humans to validate all of the spectra and other data products in the pipeline. So this is really important to support Excalibur as it grows as a tool for comparative planetology. So my question that I was asking is, how can we automate this transit spectra validation? So there are a lot of ways of doing this. And to get started, we kind of thought about what we look at when we try to determine if a spectrum is good or bad. But there are a lot of algorithms that we developed to try to see if there are things in the data that we should be concerned about. So we developed a flagging system that I'm sure you're familiar with, because if you drive, you have seen these colors, but there's a green, yellow, and red flag. So green means that it passed classifier tests, and it doesn't mean that it's necessarily a perfect product, but it means that it passed all of the algorithms and we didn't find anything too concerning. And a yellow flag means proceed with caution because we found something that might have passed a little bit over one of our thresholds. And a red flag means proceed at your own risk. So just a simple example of an algorithm that we use in the what we call the classifier task, which holds all of these algorithms, is the number of points in the transit. So we look at the white light curve, which is all of the wavelengths of light combined, and we see how many points fall within the transit. And this can tell us about if there's a lack of points, that means that it might be concerning to use that spectrum and make claims about what the atmosphere is made of because there's a lack of data. So we want to make sure that there are enough points in the transit that we can trust that data. So this is just an example of a good target light curve and a less good one that I made. So the one on the left would get a green flag for this points in transit algorithm because it has many points within the transit. But the one on the right only has 1 point within the full transit. So that would be flagged yellow or red because that's not as high quality as the one on the left. So that's just a simple example of one of the data quality flags that we would implement. So then we look at these histograms to try to see what thresholds we can set for these metrics. So on the left is one of the filters we use, G141, and that's what we use for that 62 exoplanet catalog. So on the left, you can see the points in the full transit, and you can see that most a lot of them are, okay. But Oh, uh, some of them are being flagged yellow. So then we have this full suite of algorithms in classifier that tell us about the data quality of each planet. And so all of these algorithms are run on each target, and they tell us about how many points are in the transit, as I showed in that example, and also the scatter of the data compared to the theoretical shot noise and the number of spectral channels rejected as a percentage, and also the symmetry of the light curve. So does it have points outside of the transit? So those are all important things in determining the quality of each data product. So those all come together for each planet, and we assign an overall flag of green, yellow, or red. And that can provide a supplemental metric for people. So this can kind of supplement the initial spectra judgment process, but it's not meant to replace it. So it's not like the robots are coming to replace humans yet, but it's just to kind of allow for EXCALIBUR to expand and give that initial infrastructure for the validation. So in the graphical user interface, you can see these flags. So in a state vector called classifier.flags, that has each planet's specific flag. So for example, this planet got a green flag, so that's good. And you can also see a summary of all of the flagging algorithms that were run on it. So if a planet got a red flag, you would want to be able to trace down why it got that red flag. And you could look through and scroll down on this page and see, oh, it's because it didn't pass this certain test about the shot noise or something. And so that's one way that you can look at each planet specifically if you wanted to study them individually. But another important aspect of classifier is that it allows you to do pipeline-wide flag summaries. So another state vector we have is classifier.summarize flags, which gives insights across the entire pipeline on all targets. So it tells you how many targets got green, yellow, and red flags for each algorithm. And it also gives you visualizations in histograms of the distribution of each target on different algorithms. And so this can be really useful to see where in the pipeline we might need to fix the code, or we can also compare between code bases, so versions of the code, how well we're doing. So if we change something in the code and then rerun all of the tasks, we can see, oh, did more tests pass overall, or did less tests pass overall? And if less tests passed overall, we should definitely look into that and trace back why that might be happening. So it can be really helpful for the development process as well as judging the spectra as a user. So this slide is not meant to just throw up a bunch of graphs, but it shows that most targets fall within the green boundary for all of these algorithms, but there are a few outliers that we catch. And so it is giving us good and important insights on the pipeline's performance. And these histograms are also how we set the thresholds. So we kind of wanted to find statistically justifiable boundaries for red, yellow, and green flags. And so in conclusion, classifier is a system of algorithms to flag data quality for every single target in the pipeline. And so this automates the initial spectra judgment process. It's not meant to replace it, but it can help to support EXCALIBUR's growth. As it might have over 1,000 targets, it's not feasible for humans to look manually at each data product and see if it's good quality. So it can also alert you of when to proceed with caution for each planet, and it can offer insight into EXCALIBUR's overall performance at each stage of data reduction. And along with that, it can offer insight into how well it does between versions of the code base. And so all of that provides the infrastructure validation to support EXCALIBUR's growth as we add missions and targets and instruments to the pipeline. It'll be really important to have that infrastructure for validation. So thank you so much. That's just an introduction, but yeah.
So before we take questions for Kate, I just want to point out that classifier isn't yet part of the public portal. And so this is actually one of the areas where we work with the EXCALIBur team. Like they do development, and then we figure out when the right time is to release things, and then when they're ready, that'll eventually become part of the public releases when the team is ready. It's part of the partnership. Anyway, other questions specifically for Kate? Sorry, I'm looking straight into the projector. I can't see anything. Are there any questions online, Ellen? So I actually, while we're looking, I actually have a question. So one of the criteria is the number of points in the transit. Have you started to think through about whether or not to quantify whether or not those points are evenly distributed throughout the transit, or if they're all like, on the egress side or the ingress side, and how you might use that to quantify the quality of the transit?
Yeah, that's a great question. So one of the other algorithms we have is called light curve symmetry. So that checks if we only have one side of the white light curve that has points on it, that would be flagged yellow. And if we don't have any points outside of the transit, that would be flagged red. So another algorithm we could add is definitely to see, are there just points on one side of the actual transit? So I think it would be implemented in a very similar way, but that would be another helpful metric. So this is just a basis for the validation algorithms that we'll have, but we're constantly adding more, and we're also adding machine learning algorithms to support that validation infrastructure. So yeah, great question.
All right, thanks. All right. Oh, there's a question way up there. I got you.
Thank you. Hi, that was a great talk. So as you add more targets into EXCALIBur and you add more data into those histograms that show where the cutoff for the green and yellow and red flags is there a plan in place to change where the cutoffs are as you add more data, or is that?
Yeah, that's a great question. So as we add more targets into the pipeline, those histograms are definitely going to change how they look, and we'll probably have different distributions, and we'll figure out that there are more outliers. So yeah, that's definitely been something that we've had in mind while we're implementing these. So we made it so that the thresholds are very flexible and easy to change based on the different statistics of the distributions. So we have those very flexible, and yeah, so great question.
Sorry, follow up just for user base later on. Once the flagging system, the classifier system is part of the EXCALIBur portal, will there be like notifications to users, do you think, of when those cutoffs get updated? Or
yeah, so I think that there's a log page in the EXCALIBur GUI that tells you when different things change in the pipeline and when different important events happen. So that would probably show up there, as an update.
Okay, thank you so much. Great talk.
Yeah, thanks.